Hi, I'm Mark Sherman, field representative with Time Warner Atari Games. I'd like to introduce to you our new game, Area 51. This game uses a 1 gigabyte hard drive to store the video and sound information. While the units have been fully tested, in the unlikely event that you should have problems, please follow these steps for identifying and replacing the hard disk drive. First, make sure the game is plugged in and turned on. Second, run the self-test diagnostics. Locate the self-test switch in the coin box and set it to on. Turn the game off and then back to on to activate the self-test. If the diagnostic indicates a problem with the printed circuit board, see the section on troubleshooting in the operator's manual. If the diagnostic indicates a problem with the hard drive, proceed with the following steps. First, check the 5-volt high and 5-volt low LEDs on the Area 51 game board. Both lights should be off. If one of the LEDs is lit, adjust the 5-volt power supply on the game board until both lights are off. Next, power the game off and check the power connector to the hard drive. Check that the 50-pin ribbon cable is securely fastened on both the hard drive and the printed circuit board. With the self-test switch on, turn the game back on and run the self-test diagnostics. If problems persist with the hard disk drive, you will need to call your distributor for an advanced replacement. The new drive will be shipped directly to you from Time Warner Atari Games factory. When you receive your new drive, it will be packaged in an approved shipping container. The old unit must be returned in the same container and placed in an anti-static bag, or you will void the warranty. Carefully unpack the new hard disk and check that the shock watch on the drive has not been activated. To replace the hard disk drive, turn the power to the game off and unplug the game. Static can be a video game's worst enemy. One spark and you can destroy an entire board. So make sure you touch your hand to the earth ground screw to discharge any static electricity. Carefully remove the power and ribbon cable from the drive. Locate the 4 main bracket screws that hold the hard drive in place. Remove the screws and put them in a safe place. Carefully remove the drive and place it gently on a table. Do not drop or shake the drive. Take the new drive out of the box and with it still in the anti-static bag, touch the bag to the earth ground that is connected to the bracket. This will discharge you and the bag. Grasp the drive by the edges and position the drive in the mounting bracket. Line up the mounting screws and tighten. Gently but firmly reconnect the power connector and the ribbon cable. You'll notice that the cables are configured so there is only one way to connect the cables. Carefully check this configuration and do not force them into place. Double check the connections and make sure the drive is securely mounted in the bracket before turning on the game. Carefully put the old drive into the anti-static bag and place the drive into the same box that you received your new drive in. Return this drive to either your distributor or Time Warner Atari Games as soon as possible. Make sure to include a return material authorization number and your full name and address on both the package and your packing list. Thank you for purchasing an Area 51 game, and please watch the rest of this tape for more information on handling hard disk drives.
As they pass through our hands, we can only guess where they might be going or for what purpose they'll be used. We do know that when a quantum drive ultimately arrives at its final destination, it will store the plans and ideas, the data of a great many people, people who must depend on it to deliver without fail. This one, for instance, might be used to save a life, launch a business, or help record the transactions of 1 million people. Yet how it's handled now, before it's ever put to work, could put a stop to all of it, when the people who are depending on it might need it most. Proper handling of disk drives can make the difference between a long life or a premature failure, a reliable means of storing information, or the disappearance of vital data. A hard disk drive's name and appearance are both deceiving. While its name implies rock-hard sturdiness, what makes it perform so effectively is fragile and very sensitive. When we see a drive, we see a metal box, but hidden from our view is what's really impressive. A beautifully designed, precision-made example of high technology, the product of years of research and design. While quantum drives are designed to withstand the shocks they'll receive when they become part of a system, they're much more vulnerable when they must be handled during testing, configuration, and installation. At these critical stages, following a few simple rules will ensure every quantum drive will get to the customer undamaged and perform as it should. Dropping, bumping, or rough handling can cause all sorts of immediate damage to a drive, but much more distressing to the customer who will eventually use the drive is when a drive that appears to be perfectly normal fails after it's been purchased. These latent failures are often caused by shocks that occur long before a drive ever gets to the customer. One of the most common and destructive causes of latent failure is head slap.
While every component of a disk drive is important, perhaps the most critical are the heads and media. It's at the interface of the head and the media where the reading and writing of data actually occurs. Mounted on a positioning arm, a drive's tiny heads fly only millionths of an inch above the thin metallic film that covers each disk's surface. This critical distance would be difficult to maintain even if the disk were standing absolutely still. But in fact, the disk below is spinning at thousands of revolutions per minute. For a drive to function properly, the delicate balance between these two elements must remain absolutely stable. Quantum drives are depended upon to do an untold number of tasks in many different circumstances. Yet few devices in any field require this degree of precision. When a drive is dropped, even a fraction of an inch, the head actually rises up and slaps down on the disk surface, causing a permanent flaw. We call this kind of flaw the head slap footprint because it appears as small, clearly visible marks that match the shape and size of the head. And as the disk spins, the flaw is encountered again and again by the head, causing even more damage. Each time the head collides with a damaged area, particles of the disk's material can break off and find their way to other parts of the disk's surface. Once this process has begun, there can be no turning back. In addition to the damage caused by head slap, dropping or bumping can also cause serious motor bearing damage. When a drive receives a shock sufficient to force its motor bearings into the shaft, it can create flattened areas on the otherwise perfectly round bearings. Damaged bearings like these produce increased vibration, more noise, and additional heat, factors that will lead to greater problems later.
Again, by following just a few simple rules, each of these problems can be avoided. During testing, and later during installation, when drives are being placed into and taken out of systems, care must be taken when connecting and securing them. These are critical times because there are many occasions when a drive is subject to inadvertent shock. While interface connectors require some force to properly seat them, this process is easier and much safer if a gentle touch is applied.
The same general rule applies to attaching printed circuit boards or brackets onto drives. Hold screws straight and level. Don't force them. This will keep you from stripping the screws or screw holes. And make sure you've got the correct length screw for the job before you begin.
An operating disk drive doesn't simply stop when the switch is turned off. Moving a drive immediately after it's been switched off has the potential to cause damage. After turning off the drive, wait for the platters to spin down to a complete stop before you lift it. This can take as much as 30 seconds. It's well worth the wait. Here on Earth, electrostatic discharge, ESD, is a naturally occurring phenomenon. In the electronics industry, it's an extremely costly phenomenon. The reason? Latent defects caused by ESD are often responsible for drive failure. What makes ESD such a nightmare is that it can cause damage that isn't immediately apparent.
There are simple precautions that we should be taking in order to prevent ESD damage to quantum hard disk drives. The two pieces of equipment we wear are a wrist strap and cord and a foot strap. In order for the foot strap to be effective, two things must happen. First, make sure that the foot strap contacts the conductive flooring. Secondly, you have a tab on the side of your foot strap. Make sure that that is placed either inside your shoe or inside your sock. Now let's talk about the wrist strap and cord. You always want to make sure that the wrist strap is contacting your skin. Attach the cord to your wrist strap, making sure that the other end is grounded properly. ESD precautions apply to your work environment also. Workbenches, shelves, and carts must have a padded surface with anti-static materials. And make sure carts and chairs are grounded with a drag chain.
The same care that went into handling drives during assembly and testing should also be used when packing, shipping, or unpacking them. It's easy, once a drive has been safely tucked into a box and that box has been placed with other boxes on a pallet, to think there might be safety in numbers. But in fact, disk drives continue to be subject to the same potential for dropping, bumping, and rough handling that they experienced when they were being handled individually. Of course, specially designed materials like cartons and ESD safe bags used to pack drives definitely make a difference. But when a drive is shipped, the scale of things that might affect it also changes.
While packaging is designed to withstand shock while being moved around on pallets, the drives within don't suddenly become impervious to the shock that a rough ride on a forklift can give. Forklift drivers need to remember that they are also drive handlers and take as much care when lifting, stacking, or unloading drives as anyone handling an individual drive might. When a pallet of drives is received, it's important that it be inspected for damage. But more important, if damage is discovered, it needs to be noted so the drives can be inspected and, if necessary, retested.
Quantum will continue to test and improve its packaging, but nothing will ever replace the gentle touch of a handler who knows precisely what's inside every Quantum carton. How a disk drive is handled now could put a stop to everything when it might really count. Quantum drives will continue to store the plans and ideas, the data of a great many people who depend on them to deliver without fail. Getting those drives to where they're going without damage is an important job. By following a few simple rules, it's a job each of us can handle. At Quantum, we feel we build the best disk drives in the world. Careful handling ensures that every drive will operate the way it should when it reaches the hands that need it most.